Now that we have our final regression equation, let's actually take a look at the equation and the interpretation. So the first thing that we will put together here is, let's actually write out the regression equation. And so our regression equation is going to be sales in thousands of dollars, so in 100Ks, is going to be equal to 22.005 is our intercept, plus 6.535 times June through September, plus 2.688 times May or October, plus 0.005 times adds cost in dollars, plus 3.71 times C. And so we have to remember that the June through if it's June through September, that will be equal to 1, 0 otherwise. That is an S, not a Z. If it is May or October, it equals 1, 0 otherwise. And so if it's any of those other months, it'll just be 0 and 0. And our city, if San Francisco, it equals 1, otherwise 0. Okay, so that is our equation. And so let's look at our interpretations. That's one too many T's, and Control I to make that italicized. So, sales are expected to be, let's look at, where's the dollar sign? $6,535 per month higher if it is June to September in comparison to November through April. Why are we using November through April? Because that is our baseline. It didn't have its own category because we're comparing everything to it. Now we're going to have the same statement here, except now we're going to talk about our other variable, which is May and June. So we expect in May or June that it's going to be $2,688 higher if it is, I think I said May and June, it's May or October, in comparison with November to April. Okay, so let's look at the next one. We're going to look at sales here. And so 0.005, well, and that's in thousands of dollars, so that would be $5. So sales are expected to increase by $5 for every $1 spent on advertising. It's actually not a bad return. And so how do I know that? Because, well, it's a coefficient's 0.005, and our ad cost is in dollars, so 1 times 0.005 would be $5. And then lastly, we have our cities, and so sales are expected to be, what was the last one? $3,710 more in San Francisco than in comparison to Phoenix. So that's what all of my slopes mean. They all have meaning to them. They're all talking about how they're going to increase the value of sales. Okay, let's go to the next part. And I'm going to get rid of that because we don't need that node anymore. I'm going to add in an extra row because now we're going to write the regression equation. We're going to make our prediction. We're going to do that based off the regression equation. Before I do that, I'm going to give these guys all a name. Formula, create from selection, left column. So I've named these intercept, June through September, May or October, add cost and city, once again to make it a little bit easier on myself. So it's going to be the intercept plus the slope of May or June times whether or not it's, June through September times whether or not it's June through September. And I will add to that the coefficient times whether or not it's May or October. And I will add to that my add cost coefficient times the amount I'm spending on ads, and I will add to that my city coefficient times whether or not it is San Francisco. And so there we go. We are going to make that a number with only 2 decimal points, and actually we'll make it a counting number because this is prediction, and once again in thousands. That says hundreds. That's not quite right. That's in thousands, and we'll put the dollar sign there too. And I will make that as long as it needs to be. Actually, I don't want to use accounting currency. Actually, we'll change all of these to currency too, just so they're in the same ballpark. Okay, and I'm going to center that, and I will drag that down. Pick a random one here. Everything seems to be fine. Okay, now we want to see how accurate the model is. So I'm going to figure out what the mean absolute error is and the mean absolute percentage error. So here is going to be absolute error. We're going to calculate that out. So that's going to be the ABS, which is the absolute value of sales minus our prediction. Tells us how far we are away from our prediction. I'm going to turn this to currency because we are talking about currency at this point. And I will drag that down here in a second, but I also want to start the absolute percentage error. So we'll just call that PE. And so what that's going to be is it's going to be the absolute error divided by my initial sales. And so that gives me how many percent I'm off by. And we're going to change that into a percentage. We'll give it 2 decimal places. I will drag both of these all the way down. And so once we get down here, now we will calculate out the mean absolute error and the mean absolute percentage error. Because we need that M word, that mean. So here's our average of all of our absolute errors. And so that tells us that on average our error from our predicted equation is going to vary by $1,180 per month. And then we'll do the same thing with our percentage error to find out what percentage-wise that works out to be. So on average, we are going to be off by 3.99% per month on our sales. So that is typically not too terrible. At least I wouldn't think it's too bad. Being off by 4% on the projection, I think that is pretty darn good. Okay, so let's break things out and let's look at what things look like for each of the individual cities. So we have Phoenix, we have San Francisco, and so let's find out what their actual, how they fit to the equation. So we're going to do average ifs. And so the range that we are going to average if, so we are going to be looking at let's see, what are we going to be? We're looking at the city. And since I typed in Phoenix here, what we're going to do is we're going to look at over, this will be our criteria. Will be the cities. And so our range, what is our range? Our range is what we're trying to find, and that's going to be Phoenix. And so what we're going to average is we want the absolute error for Phoenix. And we get a divide by 0 error, which means that I must have messed something up. And so what did I mess up? One second. I didn't want you to have to sit through me troubleshooting that, but the problem is I can't spell Phoenix. So there are no values there. So what I'm going to do is I'm going to copy over Phoenix so it's actually spelled right, and there we go. So our average error for Phoenix, our mean absolute error for Phoenix is going to be, put that into currency, is going to be $1,080. So actually not too far off the overall equation. So I'm going to do the same thing with San Francisco. And we'll put an F4 there to lock those in. I should have given them range names to make things easier, but can't fix that now. In fact, actually, let's go and fix that now. So data, formulas, create from selection, top row. Ooh, I've already got city going there, so I don't want to do that. No. Okay, so we'll just leave it like it is. Let's drag this down and fix it for Phoenix. Or sorry, fix it for San Francisco. And since we locked everything in, that is fine. So we're at 1,290. So it's a little bit more off with San Francisco. Now I'm going to do the same thing. I want to do the percentage errors, and that's going to be divided by 0 because I did mess that up. But I knew that was going to happen. Actually, so we're going to, it's going to come back here to Phoenix. And we're going to change this to this column here, to our absolute. Oh, so the absolute, yeah, that's right, because I did not, I only canceled city, so that actually ended up being the range name. That's fine. And so now we want this to be a percentage. We'll change that to percentage. We'll drag that out. And so we've got 3.88% on the Phoenix. And for San Francisco, 4.1, which kind of expected they'd be off by, San Francisco would be off more percentage-wise because it was off more in the mean absolute error side. Okay, so we are going to stop here. In the last video, the next video should be the last one. We're going to look at some visualizations and finish up our analysis here.